Well, dear students, now I come to the numerical part of alternating current. And please hold your NCRT book when you are watching this video. There are some simple questions just for sake of revision, which we always require. Revision of topics always required. So please hold your NCRT book class 12. What is that? Now there are some simple questions which can be asked in exam, but you, because of lack of revision, you are unable to solve. There is question number 7.6 of NCRT book, and question says 7.6, yes. Obtain the resonant frequency omega r. Especially they are calling omega r. For series LCR circuit, L equal to 2.0 Henry, C equal to 32 microfarad, and R equal to 10 ohm. Then you are asked, resonant frequency and what is Q value of the circuit? Means Q factor. You have to find it, and Q. So omega, so simply you know, is equal to 1 root LC. You are given simple calculation under root 2 into 32 microfarad. 32 microfarad. Put in farad. This mistake here is done by student very easily. So it is 1 upon 64 root 8, 10 to the power 6, 10 to the power minus 3. So it is 1000 upon 8, and it is 125. 8 1 ja 8, 2, 8 1 ja 8, 2, 8 2 ja 16, 5, 4 and then 5, 8 5 14. This radian per second is the angular frequency. Now what is Q factor? I told Q factor is 1 upon R under root L upon C. 1 upon R 10 ohm or under root 2 upon 32 10 to the power minus 6. It also becomes simple. 1 by it is 0.1 under, it is under root 1 upon 16 10 to the power minus 6, root 16 1 by 4, so it is 0.1 upon 4 into 10 to the power minus 3. This 3 will go up, it will become 100 upon 4, 25. So please do good practice of questions. I am solving these for your practice, nothing else. Now I will come to conceptual question also, which are asked in all competitive exam like AIEEE and JEEE and NEET. I will come to those questions also. Now here there is one question here. The 7.8 simple है. Suppose initial charge on capacitor 7 in this exercise is 6 millicoulomb. Total energy stored. What will the total energy later? 7.7 question है यहाँ. Charge capacitor, charge 30 microcapacitor is connected to 27 millihenry inductor. What is the angular frequency? Simple. Omega r. So I come to here question 7.9. 7.9 of NCRT book. The question says here, series LCR circuit, L 20 ohm, R 20 ohm, or L equal to 1.5 Henry, and C is equal to 35 microfarad. is connected in series across 200 variable 200 source. V equal to 200 volt and frequency F is variable. We can change. Actually, you can think like this. It is inductor, capacitor, resistor, all are in series, and here the source of variable frequency, 200 volt, variable frequency. Variable frequency. Frequency is not fixed. So you are asked here, when the frequency of supply equals the natural frequency of circuit, what is the average power transferred in one complete cycle? We say that when frequency of the source is equal to natural frequency circuit. What is the natural frequency circuit? I have told you then when alternating current flows through any circuit, electron oscillate there. Please note this fact if you have not heard carefully. When alternating current flows through any circuit, whether it is pure inductor, pure capacitor, resistor or combination, then electron oscillate. In case of purely resistive circuit, the frequency of oscillation of electron equal to frequency of source. It will be. If anyhow in series LCR circuit, actually L and C are there. And I told you when LC there, L and C are there, the frequency of oscillation of natural frequency, that is equal to 1 upon 2 pi under root LC. Because frequency of oscillation of electron in circuit depend on L and C. This is called natural frequency of circuit. Source frequency may be different. If source frequency does not match with this, then electrons are forced to oscillate with the frequency of source. I am repeating this thing. When frequency of the source does not match with natural frequency, electrons are forced to oscillate with frequency of source. But if anyhow we change this frequency and the frequency source matches with frequency of electron given by this equation, then there will occur resonance. And in that condition, in resonance condition, XL is equal to XC, or V is equal to or Z is equal to R. So here you are asked here when the frequency of supply equal to natural frequency of circuit, so what is the average power transferred in one complete cycle? So when you will write here, when frequency of source is equal to natural frequency of circuit, then circuit will be in the condition of resonance. And in resonance condition, what the value of power factor? General equation of power dissipated is equal to Vrms into Irms into cos phi. Irms is equal to Vrms upon Z at resonance Z equal to R. Therefore Irms will be Vrms upon R, and hence average power dissipated P equal to V square RMS upon R cos phi 1. In resonant condition, power factor is, so what is resistance here? Resistance here is 20 ohm. These are 20 ohm. Therefore, simple RMS value voltage 200. So P bar is equal to 200 square upon 20. Means 200 into 200 upon 20. It is 10. So it is 2000 watt or 2 kilowatt. Such questions are very important for board exam point of view, or even come because we forget what happens in resonance condition. Remember, in resonance condition, XL equal to XC. I am repeating. Resonance condition. In resonance condition, please remember this. Z equal to R. VR is equal to VRMS of source. Phase difference voltage 0. So cos phi is 1. Power factor 1. Phase difference 0. Z equal to R I maximum. तो ये कंडीशन याद रखनी होगी. Find the phase difference voltage 0. So this was one question, and repeatedly question on resonance are asked, especially in board exam and competitive exam. There is one more question here. Simply again on resonance. You are given circuit diagram here. Here is AC source. Just we have changed. It is R, it is C, it is L here. Okay. This R here, this question number 7.11 of NCRT. This R here is 40 ohm. R equal to 40 ohm and C equal to 80 microfarad. Yes, 80 microfarad. L is equal to 5 Henry. Though 5 Henry inductance is not possible, but they have given. So you are asked here 4 questions. Determine the source frequency which drives the circuit in resonance again. So it means you are asked resonant frequency. Resonant frequency you can write omega R is equal to 1 upon under root LC. Then later on you can find out FR. If you determine this, it will be sufficiently well. So it is 1 upon under root L 5C 80 microfarad. 80 into 10 to the power minus 6. Put in farad. It is 400. So 1 upon 400 root 20 into 10 to the power minus 3. 1000 upon 20. It is 50 radian per second. If you want to find out FR, okay, find FR equal to omega R upon 2 pi. So it is 50 upon 2 into 3.14. You can write 50 upon pi. Sorry, 20 upon pi. No, it is 25, sorry. 25 upon pi. But this is not required here. So one is this. You find resonance frequency. Simple. Then you are asked here, obtain impedance of circuit. बच्चों को फॉर्मूला याद है ना, Z इक्वल टू अंडर रूट R square plus XL minus XC whole square. And they first find XL and then XC, and then this find they are equal. But we should remember we can write directly in resonance condition Z equal to R. Simply write in a resonance condition, ये पूछा इसने, obtain impedance of circuit when the amplitude current and what is the impedance circuit and amplitude of current at resonating frequency. So in resonance condition, in resonance Z is equal to R. So peak value V0 upon R or V0 VRMS into root 2 upon R. So how much it is? V0 230, V0 here 230 volt. So 230 into root 2 upon 40. You can solve it. 4 5 are 20. 4 5 are 23 or 4 7 or 4 5 root 2 ampere. It is the peak value of current. Determine the RMS potential drop across three elements. Obtain the RMS voltage. So in resonance condition, voltage है 40 into 230 है ही साथ. So we need now omega L. Sorry, XL is equal to omega L is equal to 50 into 5, 250 volt. 250 ohm. And since in resonance condition, XL is equal to XC. XL equal to XC. So XC also 250 ohm. Now you are asked here VRMS across each element. Suppose R के across तो 230 रहेगी. VRMS across inductor IRMS into XL. That is IRMS I define 5.75 into 250 multiply, and then same will be VRMS across C. In resonance condition, voltage across inductor and capacitor in series LCR will be same. In series condition will be much higher than, you will find it by 230. It will come out nearly how much? अगर मैं 6 मान लूँ 3000 volt लगभग. So that is why series LCR circuit is used to amplify the voltage. I hope it is sufficient for you. Now there is one more question. Here they all are in series combination. There is a question 7.17. 7. वो कहता है कि if all these three are connected across the source in parallel, in spite of series combination, if we use them in parallel, then prove that current drawn by the circuit will be minimum. Question number 17. Here he says that this inductor, this capacitor, and this resistance are connected in parallel to the same source of 230 volt. 230 volt are 40 ohm, and this is C 80 microfarad, and then this L is equal to 5 Henry. If they are connected in parallel, then prove that current drawn is maximum. Oh, minimum. Sorry. Current drawn is circuit is minimum. I told you in one topic, and they are saying in resonance condition. I told you parallel resonance circuit. In parallel resonance circuit, I told you here, we know in case of inductor, current lags behind the voltage by pi by 2. In case of, if I take voltage this side, then I through L, inductor will be this way. And in case of capacitor, leads, IC this way, and IR this way. In case of resistance current voltage in same phase. Since XL equal to XCR for resonance frequency, at resonance condition, XL equal to XC है, so IL is equal to IC, means current through inductor and current through capacitor are equal and they are in forward direction, so they cancel. So no current will be drawn by this circuit. Though it is in parallel, current may be here, but no main current will flow here. This I will be 0. So current will flow through this, and that I minimum will be 230 upon IRMS. होगा 40, 5.75 एम्पीयर. Main in parallel resonance circuit. Actually, I have seen people saying that parallel circuit is not in our condition, no, our syllabus. But the phase difference between current voltage, you understand, between in case of inductor capacitor. So examiner may ask, and this question has been asked in All India PMT exam. Simply, what is the phase difference between current through inductor and capacitor when they are connected in parallel? What is the phase difference between current passing through inductor and capacitor in resonance condition? So that is actually out of phase. If they are not in phase, so you can say this may be current through inductor capacitor and voltage here. Then this angle will depend on value of XL and XC if circuit is not in resonance. My aim was here to explain this question to you very well. People don't solve this question in the name this parallel resonance circuit is not syllabus. No, this is not criteria of syllabus. It is criteria of knowledge.